Let's work on the concept of chi-square goodness of fit. So why do we use this test? We use this test to see if data fits a certain distribution. And let's explain this with an example. So for instance, let's suppose we go into a university in Holland and we would expect to have a following distribution of students. We would expect to have Dutch students, so a proportion of Dutch students 60%, so 0.6 in decimal format. We would expect to have Americans 20% and Swedish students another 20%. What we do is we want to compare our expectation, our hypothesis with the actual results, with the actual data. So how do we do that? We do that by taking the difference between the observed values and the expected values that we have, square them and divide by the expected value. This is our chi-square value, where we take the sum of all these differences. So basically we want to see by how much our expected value, let me say it in a different way. By how much our observed value differs from our expected value relative to the expected value. So it's the same as comparing percentages. Remember, when we have a percentage, we are comparing the final observation minus the initial observation relative to the initial observation. This is not exactly the same in chi-square, but it's the same analogy. We are comparing the observation that's happening in reality relative to what we have in mind, relative to our expectation, and we divide by that expectation to see how much we deviate, how much we differ from it. And to make it a bit more practical, let's actually give several examples. Let's suppose we have 100 students in our sample and we expect to have 60% Dutch students. That means that the expected value for Dutch students is going to be 0.6 times 100. So that would be 60 students. But suppose that the observed value of Dutch students is 77. So we want to see whether the 17 difference, so let me do it like that. The difference between the expected and the observed value is 17. We want to see whether this difference is by chance or is significant, meaning that if this just happened by chance, maybe in another sample, in another random sample in that university, we would have, let's say, 68 Dutch students. 60 from 68 doesn't differ that much. And that would be the case if this difference that we found was just by chance. But if this difference happened so large that it cannot happen by chance, then most likely we do not have 60% Dutch students in the university. Probably we have more than that. Maybe it's around 70%. That's the intuition of this test. And we do that for all three groups. We do that for the Americans as well. Let's say we expect 20% out of 100 to be Americans. So the expected value, the expected number for American students is 0.2 times 100. That's 20 students. But then let's suppose we observe that we have in the sample only 5 American students. Again, we have a difference between them of 15 students. Did this happen by chance? Could it be that in another sample we will not have such a high difference? Or is this difference big enough that it's our hypothesis that is wrong? Most likely we do not have 20% Americans, but maybe around 7% Americans. So that's how it works with this chi-square test. We are checking our expected value versus the observed value, and we want to see if the difference is significant or not. You want to see if that happened by chance or not. And the way to give a conclusion is, as always, by comparing the chi-square value with the chi-square critical value, where we have the chi-square critical value at a certain significance level. And notice that we do not have alpha divided by 2 because chi-square is a one-sided test. Why is it a one-sided test? Because we're having the sum of squared differences. Any difference to the power of 2 gives us a positive value, so we cannot have negative values for chi-square. That's why we only have alpha. We only have a positive-sided test. And the degrees of freedom is k minus 1, where k is the number of groups. So in our case we have 3 groups of students: Dutch, Americans and Swedish. So in that case we would have 3 groups of students. And by comparing these two, we can actually give a conclusion, either reject or not reject the hypothesis. And let's suppose that we would reject the hypothesis. What does that mean? If we reject the hypothesis, then we have enough evidence that data does not fit the distribution. Data don't fit what we think, don't fit the distribution. Meaning that most likely we don't have 60% Dutch, don't have
20% Americans. And one more thing, it could happen that, for instance, we still have 20% Swedish. That could still be the case, but then these values are completely off. Maybe we have much more Dutch students and much less American students. If at least one of these proportions differ from what we think, then we have enough evidence to say that the data just doesn't fit the distribution that we had in mind. Hope this makes sense, and we are done.